yeah, that was kind of interesting. Sorry about that. Okay, so as Dr. Ritchie had mentioned, I'm going to be talking about Embryology 101, and I appreciate the opportunity for me to come on here and talk about this. I know we had him on one of our webinars a couple months ago, so I think it's fair play for me to come and discuss Embryology 101. So some of the things I talk about here are going to be, you know, kind of basic, I think. And I'll go over some of it kind of quickly, but kind of telling a story and putting things together. When we look at the egg, the avian egg, let me get my pointer here. When we look at the avian egg and in giving presentation like this before, I say, you know, this could have been breakfast today. We have our albumin, shell, yolk, shell membrane, and really this was likely breakfast for some of us. And one of the reasons why it is such nutritional element for us for breakfast is the nutrient content, the vitamin minerals in that egg. Well, the reason why those are there is so we can grow a chick. I mean, chicken's not making an egg for us to have breakfast, it's making an egg to produce a chick. Therefore, everything has to be in that egg necessary to start from a sperm, from the male gamete, female gamete, to start the development of that chicken embryo. So that's where everything starts, is right at fertilization when we're discussing embryo development. When we look at embryo or fertilization process, there's a number of factors that are in play here. First, of course, we have to have insemination, whether artificial or natural insemination, and both are actually utilized depending on what part of the world you're in and what type of birds you're using. But that has to be successful, the insemination part. And then some of these other steps, and I'll briefly talk about those as we go on. The sperm is stored, it transported to the site of fertilization, has to recognize binding sites, and then we then have successful fertilization, and then that's really where our embryo development starts. However, there are some factors in there that even affect that newly fertilized egg and the embryo development long term that are involved in some of this, and we'll talk about that later. So looking at that fertilization process, where does it occur? And the avian oviduct, the top of the avian oviduct, we have an infundibulum, and that's it's up very top, kind of like a basket, I guess. And when that yolk, the F1 follicle, is ovulated, this infundibulum then will essentially catch that yolk, and that's where the fertilization process occurs. When that yolk is dropped into the infundibulum, the sperm then have to gain access to one site of that egg, the blastodisc, the little white spot on that egg. The little white spot does not always mean it's an embryo. It means that's the blastodisc, and we'll look at the difference between the two. Once it's fertilized, it'll change its appearance a little bit, and we'll discuss that briefly as well. So when that egg is ovulated, the fertilization will occur within minutes. Some of the old literature will say 15 to 20, some even up to 30 minutes, but I've done enough of this over the years, some of my own research, it's less than 5 minutes. When that yolk gets in that infundibulum, as soon as the first parts of albumin are starting to be added on top of that yolk, there's an inhibitor, a trypsin-like inhibitor, that will prevent fertilization from occurring. So it occurs within minutes. The ova then sits in the infundibulum there. We got our ovum that's ready to be ovulated. It'll stay in the infundibulum for about 15 minutes. It'll then move to the magnum, where it'll stay about 3 hours. That's where the first layers of albumin are added, kind of the thick albumin, if you will. It'll then move to the isthmus, where it'll stay another hour and a half. That's some of the additional albumins being added, and then some of your inner membranes are starting to be added there as well. And then it moves to the uterus or shell gland, where it'll spend, roughly 20 hours. Again, this is a little bit dependent on the species of bird and stuff, but this is a generality of the development of that egg, and then it'll spend just a few minutes in the vagina before it is ovulated. So what's going on here is that we've got the egg being fertilized right after ovulation, and we have it being laid after shell and egg formation. So we have a 24 to 26 hour period. Hen's body temperatures 104 to 105, 105 and a half Fahrenheit, 40 to 41 Celsius. So obviously that is a temperature that is warm enough that that newly fertilized egg will be developing. The whole time that egg is passing down the reproductive tract, we have cellular development. A laid egg may represent 40 to 60,000 cells. Some variables in there as well. You know, if that egg sits in the house longer, it's going to appear like there's more because there was more development occurring after laying. But right at lay, we have 40 to 60,000 cells, give or take. That's why when we look at an egg, unincubated egg, an infertile egg will have this compact, the blastodisc will be more compact and solid, and that fertile egg, see here, will have kind of a donut shape because again, we already have cellular development occurring. So we can actually tell the difference between a fertile and infertile egg prior to incubation. I'm asked often, well, why can't we just assess fertility in unincubated eggs? Well, there's always that 4 to 5% that's too close to call, and that number is important to us. So we generally don't do that, but we can get a ballpark idea of fertility of eggs in an unincubated, from unincubated freshly laid eggs. Another function of that is involved with our fertility in our birds is the fact that our hens store sperm in vivo. Right at the uterovaginal region, they have crypts there where they will store sperm. We can see some of these here. This is an image of a sperm storage tubule with the sperm lined up in. We can see the sperm line up down, head down the bottom. And so that would take about 30 minutes for sperm to get from the uterovaginal junction to the infundibulum. Takes 24 to 26 hours for shell formation. Hen lays an egg. 20 minutes after she lays an egg, she ovulates the next egg. So obviously there's not time for it to be right there at the time of ovulation. And so we also have some short-term sperm storage in the infundibular region. Also, if we relied on an empty oviduct for fertility, a male would have to inseminate a female within that 20-minute period, which is not likely. So that allows us to have a somewhat constant fertility in our flocks, the fact that they're storing sperm and having it readily accessible. However, what that does is that at times, if there's infrequent mating, we will have sperm being utilized to fertilize that egg that has been stored for an extended period of time. And this is just a bit of data from a bigger collection of data that I gathered a number of years ago. This would be our fertility line, and these are days after a single mating. And we can see after about 8 days, our fertility begins to drop. But like all the literature says, we can get fertility out 18, 19, 20, 21 days. But what we see happening here after 10 days after a single mating, fertility starts to drop, and this red line will indicate the percent of those fertile eggs that will die suffer early embryonic mortality. And then it'll get up as high as 50, 60+% of the fertile eggs will suffer embryo mortality. This is under perfect conditions. So most of you listening to this probably have experienced this, seen this in commercial operations, particularly in older flocks. Fertility starts to drop. We see early embryo mortality go up. Why is this occurring? And primarily because we have infrequent mating. And so these hens are able to store sperm, but they're utilizing sperm that has been sitting in those tubules for a long period of time. Partly because the way they're stored, it's the last sperm in is the first sperm out. So if hens get mated every day for 2 weeks, the sperm at the bottom of those tubules may be 2 weeks old, and all of a sudden they stop mating that hen, and then that sperm starts to trickle out. So it can actually be a little bit worse as well if you immediately pull them from the hens away from the males, or vice versa. But there's a strong correlation. So something occurs, we get embryo mortality, and then we do get a number of chicks hatch as well, and we'll kind of tie those two together a little bit later. That fertilization process, there's an interaction between the sperm and the egg. The sperm must recognize binding sites, as I mentioned in that earlier slide, and then the membranes fuse. They release enzymes. They actually digest a hole in that membrane. That sperm then passes through that hole we can see here in the avian system. Another diagram of the same thing. A hole is generated. One thing that's different in the avian system as opposed to the mammalian system is we can have physiological polyspermy, meaning we can have more than one sperm pass through the paravoline layer, which is analogous to the zona pellucida. In the mammalian system, that would be pathological polyspermy. You get two sperm in, then there's death of the developing egg and embryo. We don't have that in the avian system. However, we can have a bunch of sperm here penetrate that paravoline layer, but really only one contributes to the fertilization process. But there will be a lot of them that gain access, but only one actually passes on its genetic material. You can see here some of the early work we did, we're able to look at the sperm cells in one of the holes they generated. Using that, and I'm not going to talk a lot about this, but I developed a test a number of years ago where I could count the incidences of the sperm penetration in laid eggs. We used it for a research tool, and then we went out into the field and started using it. So we can see every little dot here would be a site where sperm had penetrated that paravoline layer. And so we were able to correlate all this. Okay, how many days past mating, and what happens when we've got this amount of fertility? What are we likely to see with holes, these sperm holes, and tie a lot of things together. So that's just a factor that has to occur. And I can go on and on about that as some of the things that our selection process over the years have done to change this a little bit, but we'll leave it at that for now. So again, fertile eggs, we start to see that embryo development. Without incubation. So if we take that same egg and give it 12 hours, roughly 12 hours of incubation, you can see that donut starting to grow a little bit more. And at 24 hours, we see it growing a little bit more. And so this kind of ties into when I'm going to touch a little bit on embryo diagnosis, but that's not the point of this presentation. But that's what I always like to tell people is if you're trying to evaluate this is a normal developmental pattern. So if you see a normal yolk and a chunk of tissue back here, but you don't see anything growing around that dermal disc in this organized fashion, you know, you're looking at some other tissue, a meat spot, a piece of follicular wall, or whatever. So we're looking for this is a normal developmental pattern at 24 hours, roughly 24 hours. So when we look at the avian system in general, we have the initial proliferation of the cells, we have differentiation of the tissues and cells there that make up the embryo, and that newly hatched chick then will grow to the point that it escapes a shell and goes on with its life. Now, how many factors in the incubation process will affect the chick afterwards, and we'll talk a little bit about some of those. I had to put this little picture up here from the International Hatchery Practice. I'm sure all of you are aware of that, but this was an image I took. I wrote an article in this issue, and this is an image I took, and they said, we have permission to put that on the cover, and I just was very pleased with myself. And so I said, sure, you could have that on the cover. But a lot of good information we can find in a lot of different material out there. So what does the embryo require? When we have our eggs, of course, now we've got these fertilized eggs, and we're trying to mimic Mother Nature, mimic the mother hen. So what is required then to really stimulate this process? You know, initially, commercially, we try to then slow that process down. We can't stop that metabolic growth, but we want to slow it down to the point during egg storage that it's a viable embryo still to be started back up at the proper time. We do that with heat. So what does it require? Heat. Requires fresh air. Actually, it requires a lot of cooling. This was something years ago when I first started this. I mean, I grew up hatching eggs all the time at my house as a kid, and I just had this vision that incubators supply heat. Well, in reality, now we look at our incubators, and the most important role that they that they offer is cooling and universal cooling throughout the cabinet, so we don't get overheating. Dr. Ritchie and I have done had several discussions on this to other clients and whatever about the effects of that overheating on the embryos, and it's very harmful to that developing embryo if we get these hot spots or hot incubators in general. So really the cooling factor of our incubators is I think much more important than its ability to heat. And then we want to exhaust CO2 and humidity and add oxygen and different things. So it's a function that we're trying to mimic, again, what Mother Nature did by providing the things that she would do. So what are the 4 basic requirements? Again, not going to talk a lot about these, but bring them up. Is the 4 requirements to develop that embryo is proper temperature, proper humidity, turning of the eggs, and ventilation. And we're doing that all, managing every step along the way to try and get the newly hatched chicks. So I'm going to show a little video here. Hopefully it's going to play correctly. I had a problem with it a little while ago. And this is one I borrowed off a site. I think Dr. Rich has used this as well. I think it really kind of summarizes embryo development in a very good fashion. So it's about 2 minutes long, and then I'll kind of explain some other things as we go along in there. And looking at these developmental patterns, there's a day marker on the lower left, show you what's happening at the different days. And as you look at this and kind of read what's going on, that day these things are happening is very important. You know, like a lot of things in life, things have to be done, accomplished in a very orderly and systematic fashion. We can't just do things at our convenience. Everything has to be done in its proper space and time and place to get that embryo to grow correctly. So you can see some of the different parts of that bird developing, the down, the scales, feather follicles, various stages. And I won't go through this in here, but we can go through every single day and say what's happening with that embryo every single day if we want to. Some very good material that's out there on staging of embryos and embryo growth and development. Some of it's pretty old, but it's the same now as it ever was. So we see that embryo growing, filling that space, getting ready to initiate the hatching process. And chick will then pip, and we see a hatched chick come out. That's what we're trying to do. I think that's a very classic and good description of what's going on from the poultry hub there. So as I mentioned, everything has to be done in a proper form and fashion. I worked construction many years ago, and I did one part of it. I hung the sheetrock in houses. And I know when we walked into a house, that foundation better be done, the framing better be done and square, the electricians need to already been in and out, the insulators, the plumbing, everything has a order that it has to be done before we come in there. We can't go and do our part and then have somebody come back later and fill in that part. It just doesn't work. Embryo growth and development is the same way. That's why it's so important at every stage of development, at day 2, at day 4, at day 6, to provide the proper environment for that embryo so we have the embryo has the ability to grow in the order and fashion that it's supposed to. So it's like building a house. We have an order we have to go through. The other thing I've been asked a number of times is, why haven't we've seen the growth rate of broilers, for instance, dramatically shortened over time. Why isn't our incubation process shorter? And in actuality, we could slightly shorten it with extra heat, but that's at the detriment of the quality of the chick. So we actually have to manage our heat load and temperature in our machines to get that development stretched to the point that everything is occurring in the proper manner. So we do a lot more cooling now, I think, than we used to, because of the heat load that's there, because we can't have them growing too fast and trying to rush the process, so to speak. So one of the things that's occurring during this growth is cell differentiation. So embryonic cells are relegated or assigned to become specific parts of that developing chick. You know, for instance, we have three layers: ectoderm, mesoderm, endoderm, and each of these will produce different parts of that bird. And that differentiation relegation is a very critical part that occurs in that embryo. When we look at a normal mortality pattern, this would be day 0 to 21 of incubation for a chicken, and similar for a duck or a turkey, just stretch it out. But we get a peak in mortality here in 2 to 3 days. That's when a lot of our cell differentiation is occurring. And so if we get a system, a point to where that is not occurring properly, the embryo will die. And some of that is biological. It'll happen. It coincides with every animal in the animal kingdom, including humans. There's a point in time of embryonic development where if things don't happen right, quit, stop. And that's oftentimes during that point of cell differentiation. It's kind of nature's way of controlling the quality of what's been produced. So that cell differentiation early on, this is a normal pattern we see, and there's really, we have to accept a certain amount of that. When we look at the growth of that embryo in general, first 0 to 10 days, maybe 12 days, there's differentiation occurring at different levels. A lot of it happens really early on, then there's more occurring. So we see growth of the embryo, more of the internal components of the embryo, and then we get out to days 11, 12, 13, we really hit that growth phase. And so those of us involved with incubation know that that's also the time there's a lot of heat load coming in those machines, because there's the growth is rapid at this point. Most of the parts and pieces of that embryo are there, put in place. The cells that are supposed to be the brain, kidney, lung, liver, whatever, are in place where they're supposed to be. And now we're just growing the chick. And that happens at last 11 days and beyond. So what happens early on? These are very important functions that happen early on that affect that embryo long term, and that's why we have some embryo mortality when things don't occur properly. The yolk sac, its purpose is to secrete enzymes to change the yolk contents into soluble form for absorption of the nutrients to the embryo. What happens if that yolk sac is not formed and developed properly? Obviously, the embryo is going to starve trying to get nutrients, because the function there is to allow that yolk contents to be utilized. The amnion, here we can see is the fluid-filled sac surrounds the embryo. It functions to transport that fluid in which the embryo floats, protects the embryo, helps the growing parts from adhering to each other, and gives the embryo a lot of space. That amnion is also occurring very early and is a very critical part of the embryo development. The allantois is developing. Starts really early. We start getting development of the allantois. It has some major functions: respiration, oxygenation of the blood, removing CO2, excretory function. We can see in our eggs when they hatch, we can see the little white deposits in that shell. Those are the urates, part of the waste that chick is removing from the metabolic processes. And the allantois plays a role in that, and also plays a role in digestive system, aids in utilizing that albumin and absorbing calcium from the shell. So these are some very early membranes that are very critical. The serosa or chorion, they lie close to each other, and they'll fuse to form the seroallantois membrane. Function oxygenation of the blood, carbon dioxide removal, and very important in development of that embryo. So these things are some of the very early things, and if they don't occur properly due to problems during incubation or whatever, then we'll have problems obviously later on. So we can look at during the gastrulation stage, the eggs as they are laid, freshly laid egg is near the gastrula stage. These layers, the mesoderm, ectoderm, and endoderm, are formed there, and again are very critical with development of the of the egg, those 3 primary germ layers. And then at oviposition, the embryo is like I said, late blaster, early gastrulous stage of development. So some of these things have occurred before we even have the egg in our hands out of the chicken. So again, looking at some of these same things we talked about. Actually, I'm surprised these are here because I deleted those once, but so we have double of something there. Kind of caught me off guard that those are still there. So we look at the eggs themselves, and again, this is not a troubleshooting exercise. But if we look at infertile eggs, no development at all, we'll see a very compact germinal disc area, and decreased mating frequency is the primary cause of that. And I'll say this over and over and over. Been doing this 25 something years. I'd say 90% at least of the time I see problems with fertility, it's decreased mating frequency. So I've used the old adage, if you want me to help you get better fertility, just get your birds to mate more frequently. Not as simple as saying it, but that really is the biggest function we see that causes some of our poor fertility. And again, our eggs at 12 hours of development, we'll see a germinal disc similar to this. Day 1, if we have loss in day 1 of incubation, I mentioned the low fertility, infrequent mating will cause some early day 1 losses. Pre-incubation or poor egg storage, improper egg holding time. If we're holding eggs too long, if we have fluctuating temperatures, you know, in the egg room or in the egg house or during the transportation process, we're going to have some early day 1 embryo loss. Day 3, very similar functions. Days 1 to 3 is kind of, to me, it's kind of that same thing, and I'll show you a little bit how I break these up to really evaluate our embryo growth. Is those are similar. We can look at the same probable causes. We see that day 3 embryo has a heart, brain, it's functioning in its way. And so it's a critical time for that embryo as well. Day 4 is when we see the eye pigmentation. I bring that up because as I like to, when I'm evaluating embryo growth and development in a function to try and see our machines operating the way they should, how we determine when they died and during the incubation process really allows us to address the issue better. Day 4, similar as we said before, poor egg storage, pre-incubation, not quite as much of infrequent mating. That's more of a real early embryo loss, but we'll look at some of the things happening in day 6 of that embryo development. Day 8, the egg tooth is very visible. And that's kind of one of the things that I'll point out in a little bit. But the time period between day 8 and 15, and I'll mention it a little bit later, but we look at it being as a nutritional poor nutrition problem if we have a lot of mortality in that 8 to 15 range. And in my 20-something years, I rarely have seen this. I have seen, yes, like everybody, I have seen broiler feed be dumped in a breeder house, and that has horrible effects on hatchability and high embryo loss. But it's not a consistent poor diet they're fed. It was an accident, but we will see that. But if there's a real poor diet, most of the time in our breeders, that will be reflected in their egg production, because they're going to lay eggs when conditions are right. And if they've got a poor diet, poor environmental conditions where they're living, the egg production will start to drop off often before we see eggs produced that have poor nutrient contents that cause mortality. Day 15, we start seeing gut drawn within that body. Again, if we see between 8 and 15, a lot of embryo mortality, we kind of look at nutrition, and I'll kind of mention that a little bit, what we expect to see. Day 19, the yolk sac is mostly drawn into that body. The amniotic fluid is mostly gone. And this is where we start seeing some different things okay, if we see a lot of losses at this point, there's a number of things that can cause these. Our vaccination process, because day 19 is after they've been in ovo vaccinated, if we're using that process. Inconsistent poor transfer, eggs are left out too long between the incubator and the hatcher. And so we have sitting out, maybe getting cold, maybe getting hot. We've seen both. Or we have some incubation problems with temperature, humidity, ventilation stuff. That's when we really start looking at what happened in the incubator when we're looking at late embryo loss. Day 20, kind of the same thing, but now they've been in the hatcher for a day or day and a half, depending on when you transfer, maybe 2 days even. We can start looking at some hatcher issues, ventilation, temperature, as well as some incubation issues. So we start getting here to where we see it could be either incubation or hatching. On day 20, again, if you have shell quality issues, time of transfer, we can see some issues there. So why do we see this other peak here in embryo mortality? Remember I talked about that early peak when cell differentiation does not occur properly? At day 19, roughly about day 19, that embryo makes that internal pit into the air cell. And that's the first time it tries to respire using its pulmonary respiratory system. Before that, it's using its circulatory system. If that makes that PIP, tries to initiate that pulmonary respiration with the breath, and that doesn't switch over, it's going to die. And so we have some of these losses, they're biological losses that switch does not happen, and we get some mortality there. And so then our last peak is just hatch problems, and there's a number of reasons we could have that, basic hatch problems. Upside down eggs, lack of turning, even heat, different things like that. But these are the 3 areas that we're going to see mortality even in perfect conditions. And I have to say this a little bit because with this has become an issue lately. We're dealing, not really an issue, but we're dealing with a biological system. I think everybody needs to understand this is a biological system. We can expect mortality. They're unavoidable. Fertility, the very best we're going to get is 1 to 2% infertile. A lot of variables in there, but that's the very best we can get. Embryo mortality, when I look at that as a 4 to 5% total embryo loss is going to occur. We just can't, we're not going to get 100% of anything. Now, when we start straying from these numbers and values, that's when we start saying, okay, what's happening? We're looking at some hatch data from somebody not too long ago, and they sent all their breakout data, and amazing, for weeks on end, they had 0 early embryo mortality. Well, that just doesn't happen. And we told them that something's going wrong here. That does not happen. We're going to get some embryo loss. And so we'd have to know what's normal and acceptable. And, I've kind of followed this rule, 2 to 2.5% in that first week, 2 to 2.5% in the last week, and then less than 0.5% in that middle. And just briefly going over these areas, that first 7 days, we have cell differentiation occurring. If we have higher mortality, poor egg handling, age flux, infrequent mating, long egg storage, fluctuating temperatures. And then when we look at days 8 to 14, that middle week, again, we primarily look at nutritional causes, but we shouldn't see more than 0.5%. We just really shouldn't. And more often than not, when I see that more than 0.5% in that middle, they're really calling some days 6 and 7s 10 or 11, or some 16 days 13 or 14. We rarely see that really being elevated. If it is, we know where to look. And then that last week, again, about 2 to 2.5%. This is when they switch to pulmonary respiration. This is when their hatching position is supposed to be fixed in that developing embryo. All these things go back to, what happened in the previous 18, 19, 20 days. When I was teaching classes at university, I used to tell people, you get 50-week-old flock that's not performing well. What do? Well, you go out and cross your fingers and hope everything you did before that worked, because you can't really fix it. And often that's the same with our incubation. If you messed up some stuff, had some hot temperatures in that first week or cool temperatures, it may be reflected here in that last week, and you often can't correct that. You're getting what you produced through the rest of your incubation time. Again, that embryo has to develop in the pattern it's supposed to, or in the manner it's supposed to, in the time frame. So this is kind of a way, and again, this is not an embryo diagnosis talk, but I like to bring this up because when we're talking about embryology, and wanting to know how they should develop and what's normal. I think evaluating that is helpful when we can determine when we have losses properly. So this is a sheet I use, and I break mine up 0 to 3, 4 to 7 days that first week, and I separate the two because there is some potential differences in a lot of 1 to 2 day dead as opposed to 6 to 7 day. But then I also have a total early. I always like to say, what was my total early? And our middle, what was our total middle? And then our total late, then total embryo loss. And for me, I've tried to make everything as simple as possible. At day 4, eye pigmentation should be prominent. So if you don't see a pigmented eye and it's fertile, it's here. If the eye is pigmented, it goes here. If you see an egg tooth present, prominent, it goes here, because that happens at day 8. If we get prominent chick down covering, it's progressed beyond this. Now we've got a day 15, 16, 17, they'll chick. If we see yolk sac withdrawn mostly into the body, then we've hit that 19-day period. And this is our transfer time as well. So stick to these points right here. We can split these up and we can see, okay, where are we having our losses when we're looking at embryo development. And just real quickly showing you what I see. Pigmented eye, prominent. Don't look for it, it'll pop out at you. Egg tooth, don't dig around and look for it. Do you see that tooth sitting on top of that upper beak? If you do, it made it 8 days. Prominent down covering at day 15 days, and yolk sac withdrawn at 19 days. And so then if we do that and we're trying to evaluate our embryo growth and development, again, trying to ascertain if what we've done in our incubators was adequate and correct, and we've given them what we need, because that's the beauty of our single stage incubation now, is that we can set temperatures and environmental conditions for a 1-day embryo, for a 3-day embryo, for a 6-day embryo. We haven't been able to do that in a multi-stage. We create an environment that tries to give us that, and it does a pretty good job. I'll say our multi-stage do a pretty good job of that, but our single stage, we can really give that embryo what it needs. We get it started off right in the first week, and then we maintain after that. Don't let them overheat. Let them continue to grow without overheating, because there's definitely some detrimental conditions with overheating. Like I said, Dr. Ritchie and I have done several meetings on that, and performance of those birds long-term will definitely be affected if we have some incubation problems like overheating. We get too many embryo losses here. Egg handling, almost always look at egg handling first there. Don't look at your incubator functions. I mean, I've tried to kill embryos with excessively high incubation temperatures at day 2, 3, and 4, and excessively low, and I typically still would not see the death until 8, 9, 10 days. I'm talking a degree to degree and a half Fahrenheit above or below what's expected. If we see a lot of mortality there, we'll look at egg handling. If we see a lot in this middle, we'll look at nutrition. If we'll see a lot too much in that last week, that's when we start looking at our incubation or our hatchers, really. So we can kind of separate the two out of what's going on with our embryo development. And so how does this affect, I know the title of this is how this all embryo development and growth affects our commercial poultry production. And I'll just show a couple of bits of data that I gathered over the years. Hatch and egg storage, we stored eggs for 0 to 5, 6 to 10, 11 to 15 days. We set them in these independent groups, looked at hatchability. Our hatch was low here. We used a low insemination dose to not flood the birds with too much sperm, but show us some separation if it was there. Definitely when we stored the eggs, it's exactly what we expected. Lower hatch of fertile. That's where we start getting these primarily early embryo mortality. But the interesting thing is when we look at those birds that did hatch, when those eggs were stored longer, we had lower 7-day weight, lower 0-day weight, 7-day weight, 14-day weight, and higher 7-day or 14-day mortality actually on these. And so factors that occurred, this is even before incubation. Now we caused us to see some embryo loss in the incubators Those chicks that didn't die, embryo loss, that hatched, were also stressed. We know what stress does to birds. So I always look at that, and I'm sure most of you that work in the hatcheries can see, okay, our best hatching flocks typically will be our best producing birds. There's a strong correlation there. So factors that are occurring even in our egg storage will affect our embryo. Every bird that was in there was stressed to one extent or another that had this long egg storage. So even those that hatched will be affected in their performance. This was looking at in vivo sperm storage when we stored eggs for longer periods of time, or not stored eggs when we had infrequent mating. We mated the hens and then pulled the roosters away. We did artificial insemination. And then so we had eggs that were laid 11 to 15 days after a single mating, and 0 to 5, 6 to 10. Hatch was obviously lower. Hatch of fertile was lower. Fertility was obviously lower as well when we looked at 2 weeks past a single insemination dose. When we look at livability of those broilers, same thing. Even though we got fertility, so we can correlate this with older flocks. Poor fertility in older flocks, increased embryo mortality in older flocks. The broilers coming out of those houses are going to struggle to perform as they should. We're dealing with this a lot in the industry and throughout North America right now. A lot of people are having some fertility issues, and I don't really know how to exactly correlate that with the losses of production that may or may not be occurring, but it is definitely there. And so it's kind of a double-edged sword when we get infrequent mating or poor fertility due to infrequent mating. We're going to get poor broiler performance, as well as storing eggs too long. I was working with a customer a number of years ago, and they just did not want to dump eggs. They had so many eggs. So they were, for several months, they were setting eggs 12, 13, 14 days of storage. And they just, hatch was poor, broiler performance was poor. They would have been better off just getting rid of some. So looking at infrequent mating, again, this goes back to this graph I showed you earlier. Infrequent mating, fertility drops, embryo mortality goes up, early embryo mortality goes up. Also, 7-day mortality goes up from those that do hatch. And when we follow that out, looking at feed conversion and performance of the broilers overall, that also gets worsened when we have the same. So tying this together, you know, our fertility levels, our egg storage conditions, our incubation. I did a class several months ago, and they brought eggs in for us to evaluate and look at the embryos and embryo developmental patterns, and never seen so many abnormally developed embryos with exposed brains and everything. And it was atrocious. And I was almost afraid to ask what incubators they used. That was not the point. They said, well, in the first week we had we had hot temp alarms numerous days in that week when they were young, and it showed. So then I go, well, how did the other birds perform that did hatch? We don't know. They sent them out in the field, and I suspect that they were going to be very poor performing as well. So what does this all mean? Of course, by ovulation, there's 1-day development of that avian embryo. How long we store it, how we store it, incubation conditions will affect that developing embryo. Care must be taken to protect that embryo in any way we can. When we talk about egg handling, it's like egg leaving the farm, we've got a fertile egg. How is it transported from the farm to the hatchery? What kind of transportation equipment? How long is it put in the hatchery? How well is it stored in the hatchery? Because those all will contribute to our viable embryo production. Again, our embryo has to do everything in that same order. We start stressing it, put kinks in the armor along the way. It's not as able to catch up. It can't really repair as much and catch up. So we're just compounding things if we have a lot of problems. Again, like I showed, storage length and fertility frequency will affect hatchability. Mating frequency will. Point is that any stress in egg handling or incubation process will affect embryo and chick productivity. So I didn't really talk exactly about what that embryo needs. You know, if I was talking about everybody with like single stage equipment, we can say at this day they need this temperature, and this day we need that temperature. We have some profiles we develop, for incubators to try and give that embryo exactly what it needs. So all the developmental patterns occur in the right order and process and timing. When we have multi-stage, it's a little bit different situation. So I didn't really bring that up. We probably have people that may not do that exactly, but may not have the ability to use single stage. But it will definitely affect any process, any stress in that process, incubation process, whatever, will affect not only the embryo itself and its quality, but also the chick productivity after they hatch. So with that, I will finish, and I guess we're going to entertain some questions.
Thanks. That was terrific, Keith. Thanks very much. There's a couple of questions in the inbox there. I'll get them, or a few there, and I had some sent to me. We've got, what's the time here? Got a few minutes. Here's question number one. How does sperm avoid being incorporated into a developing egg in the oviduct? How does sperm avoid being incorporated into a developing egg in the oviduct?
How does what?
How does sperm avoid being incorporated?
Oh, okay. How does it avoid being incorporated? Yeah. Well, there's two rules of thought of how that's basically the sperm has to be modal and move its way from the uterovaginal region to the infundibular region. So it does that between the time that egg, when an egg passes. One school of thought is that when it passes the distension of that oviduct, then causes these sperm storage tubules, you have a movement of them and sperm will trickle out. They'll then move up that oviduct and get to that infundibular region and be ready for, and then be stored in those sites and be ready for fertilization. The other thought is that the sperm are constantly trickling out. So if you were to take a laid egg and look at that laid egg, you'll most likely have some sperm that are incorporated in that albumin. Because as that albumin is being put down, there most likely there will be some sperm in that oviduct somewhere. So it has to move in that period of time when that oviduct's empty, which makes that's why the sperm storage is so critical, because if we didn't have that hen would have to lay an egg, jump out of the nest, the rooster would have to run and mate her immediately so that sperm can start hightailing up to the top of the oviduct, and then it's just not going to happen. So that's why. So it has to move when that oviduct's empty.
Right. Right. There's a couple of questions that arrived via text directly to me, and one of them was really interesting. I thought you mentioned early on about having eggs for breakfast, which is pretty popular, and there's a lot of specialty eggs out there, omega-3, D3, etc. Is there a lot of research on diets like that may help our chick quality, vitality?
There is some research, and without saying too much and stepping on some toes, potentially stepping on toes, from my experience and what I've researched and looked at all the time, the hen, you've got this egg here that everything is supposed to be put in that egg to grow that embryo. So can you like add extra of a certain vitamin or mineral or whatever and have it put excess in there? Well, would it then also have to put extra of other things to keep things in balance?
Right.
So I think the hen itself, this is nature occurring, and she's laying an egg to produce an embryo. I think it's harder than we think to manipulate what she's going to put in there, because everything's got to be in a balance. Right, I'm not saying it can't, because there's some research that'll show, yes, this seems to help a little bit, this seems to help, but I think we're almost fighting nature, because that hen's like, well, I don't want to put twice as much protein or whatever in there, because how does that affect everything? There's a balance in there. So there are some, but I think we're fighting nature and trying to do too much of that.
Here's another one. When you're looking at shell debris, what are the most common causes of all the manure on the shell and the higher jagged pip lines?
If you've got a real high pip line, you probably don't have enough moisture loss. And I didn't really talk about that in there, but when an egg is laid, well, when an egg is in the hen, there's no air cell. I mean, I've actually been posting hens before and cut the oviduct open and been in a quiet lab and set the egg on a counter, and you could hear the pop when finally there's enough moisture loss and the air cell develops and grows. From that point on, that air cell is going to enlarge due to moisture loss. Well, if you don't lose much moisture, that chick's going to fill up that whole environment, and so it's going to pip really high on that egg. And so then we're going to have if you're getting a lot of really high PIP lines, we need to look at our moisture loss. We typically want to be around 11 to 12% moisture loss from time of set to transfer, depending on the 18-day transfer, depending on the machine. A little bit difference on the machines, but that's a ballpark where we want to be. Right. If we're getting a lot of manure on the eggs, we can look at a draggy hatch. If you've got high PIP lines, you probably have a lot of chicks hatching that don't have enough moisture loss, probably have a lot of open navels. And so you're going to see a lot of mess on the eggs, as well as the chicks are moving about the hatch basket.
Okay. And I guess the other side is that there's a lot of blood on the
right.
That would be too early. Right?
Yeah. Well, too early, but if you don't get enough moisture loss, you might still be out 510 hours of incubation, but if they're just not losing the moisture, some of those are going to have a tough time with that navel closing, even though they have adequate incubation time. So we can't really say they hatched early. We just didn't allow them to lose the proper moisture. And if they don't, that navel's it's going to be difficult to close up properly.
And then this question's probably part of it too, but it's talking about the navel strings that are attached.
Mm-hmm. And what could be causing those?
Yeah.
We can have, if you've got a lot of the real strings, you could have some high temperature. Basically, you've got almost a chick growing a little bit too fast.
Right.
So you're starting to get that navel closing before that yolk is completely withdrawn. Okay. And so you've got a little bit hanging out of there. And that's primarily what we look at on there, is a little bit high temperature. If we have a lot of strings. Now, again, everything is going to happen.
Right.
But if you're getting a lot of it, and that's what I always like to see, if somebody say, hey, I saw a string, what does that mean? Well, if it was in one chick, I have no idea.
Yeah.
If it was in 5% of them, okay, we got a problem.
Yeah, exactly. Yeah. So relative to how many. Here's another question. What's the most common cause of transposed malpositions? So that would be the head. The head's usually under the right wing, I believe.
Right. Yeah.
And also a compliment on thanking you for the presentation. So the question is the most common cause of transposed malpositions, head in the small end.
Oh, head in the small end?
Yeah.
Most of those are going to be the eggs were set upside down. Or you start getting a situation where you got a lot of really round eggs, but most of our breeders that we deal with don't have a high occurrence of that. But when we see a lot of upside down eggs, primarily we start immediately looking at we have too many set upside down when they're gathered. If we're doing an ovoject, we can tell that pretty quick. And I always do that when I do a residue breakout. I'll look on there and say, okay, yeah, here's the air cell end, PIP line. There's a hole where the ovoject went in, and I'll look on that. It's like, oh, it's not there. Open it up. Yeah, it's upside down, and you see it on the other end. But if you don't do an ovoject, then sometimes you don't know for sure if they were set upside down.
Yeah. Okay, another question here. Which eggshell temperature would you consider being overheating in a multi-stage machine?
Yeah, what we like to stay, we always are going to want to stay in that, particularly depending on where you're looking at in the machine. Early on in the first 24 hours, we want a fertile egg to be roughly what the air temperature the set temperature is in there. Then on the other end, 100.5, in position buggy 6, we've seen 100.5, not 105. Right. We would want to be at 100.2, 100.3 in that range. But just not too long ago, we had some customers saying, hey, we're getting 101, we're getting 101.5. We're even getting some 102, 102.5. That's definitely start causing a problem. We want to be in that 100.5 to 101 range for the and the 6th position and like in a Jamesway machine, right. The last few days of incubation.
Excellent. So we've got some more questions. We've got a couple minutes, so we'll do our best. Yep. Couple that look like they're related. What makes the navel not close properly and black button navels?
The navel's not closing like we talked about. You could have high humidity, so we're not losing the moisture on there. You can have low temperature, so they're developing slower than they should be, so they're getting to that point of hatching, and the navel's not closing properly because they're a little bit slow developing, and the humidity is too high. We're not losing moisture, and they're going to close. The black buttons, sometimes that can actually be an overheating type of issue, or if we've got some unclosed navels and some yolk material out, they'll start drying and looking black. I mean, essentially the blood will start turning black. And so it really depends. I mean, you have to kind of look at it to know. A lot of times those go together. The black buttons, I think, a lot of times go with the
like aged blood, right?
Yeah,
exactly.
And that's when we do a breakout. You know, I hear a lot of people doing a breakout, and all that egg's rotten because it's black inside. Well, not necessarily, because that blood is going to turn black after, you know, another 2 weeks of incubation. So
right. So I think let's see here. There was a couple. Well, here we are. There's a request, Keith, for you to do a seminar on hatchery residue analysis. So there you go. I
have done that, and I'd be glad to do it here. The other place you can find that is on our website, Jamesway.com. We have our list of webinars. Actually, last year I did 2. I did a hatch residue 1, hatch residue 2, a 2-part series. First one, I went specifically on the residue breakout early, and the second part, I had some of our other consultants on there. It was kind of a team approach, and we went through the things we're seeing in our late deads type of thing. So I would be glad to do one, but I think you'll get a lot of your questions answered. You can go to that list. It was middle of last year. I'm not sure when, but I did a 2-part series. So there's quite a bit of information there, but sure, I can do that. I'm actually doing one this Friday for remote training for a customer. They wanted me to do it personally to their group by, team. So we can do that too. So
my personal opinion is hands-on is better.
Hands-on is definitely better. And we're starting to get to the point we can do a little bit more of that. So,
I understand, but hands-on is terrific because there's other dimensions you pick up.
Absolutely.
Namely smell.
Absolutely. Also, the webinar we're going to be doing in 2 months, I'll be doing that webinar, and we'll be doing hatch residue, and we're going to be doing it live. It's not going to be a PowerPoint situation. It's going to be actually breaking them open in baskets and looking at them. So that'll be a little bit better, like PowerPoint type thing. But yeah, when it's a little bit more open, we do a lot of hatch residue training. So, they can contact me, and either myself or one of our guys can be glad to come and do some training on site.
I thought the video you used that was produced in Australia was terrific.
I know you've used it too, and I've used it. It's really
good. It's just terrific, and it shows a lot of what's going on and how complex it is. But thank you very much. The timing is perfect. A couple of questions have come in, but I think we'll end it here. Thank you to all our sponsors and Keith for all that work, and we look forward to our next presentation in what are we, July now? August. Oh my goodness.
Yeah. Years flying by.
And just so everyone knows, we hope we can flock together again at our normal meeting in May 2022. So we've reserved the banquet room. So there you go.
I'd love to come to that. So
and the borders are now officially going to open to our U.S. friends on August the 9th. So that's terrific.
Without hoops and hurdles.
I'll go fishing before you all arrive. So,
all right.
Okay. Thank you.
Thank you much.
Bye-bye, Keith.
All right. Bye.
Thank you.